this practice session, we'll learn to work with NumPy and its various functions. Let's begin. Let's first import it with the alias NP. B is an array with two sublists. This is B. And this is the second value in the first element, 7. B has 2 rows and 3 columns, and it has 6 values in all. This is an array with the values 0 to 6, and this gives us a 3 by 3 array with random values. This is a 2 by 3 array filled with ones, and this is a 1 by 2 filled with zeros. Here a 3 by 3 array with ones on the left diagonal. This fills a 3 by 2 array with sevens. And this gets us 4 equally spaced values in the interval 1 to 2. This creates an array with 3 elements but gives it a depth of 3, and here the values 1, 3 and 4 turn into complex numbers. Again, this is A. We can reshape it to a 3 by 2. Now it's of 2 dimensions and each item is 4 bytes in length. Let's change A again. This one gets the values at positions 0, 0, 1, 1 and 2, 0. Indexing with this index gives us this array. And now consider two arrays A and B. Add A to B. Subtract B from A. Multiply them. Divide A by B. These are the square roots of all the values in A. And this is the sum obtained by adding all those values. This is when we add them along the x-axis. So 1 plus 4 is 5, 2 plus 5 is 7, and 3 plus 6 is 9. We can also transpose a matrix. Now this is array V, this is W, and this is their dot product. Let's do some problems on this now. The mode. Write a function that generates a NumPy array, then gets us the most frequent value from it. We create an array holding 5 random integers between 0 and 7. Argmax gets us the indices of the maximum values, and bin count counts the number of occurrences of each value. So we get how often we get the value that occurs in this array the most. Nearest value. Write a function that creates a random NumPy array of size 5 from a uniform distribution in the interval 1 to 7. Then returns the value in the array that is closest to a value it takes from the user. This is the nearest function. It takes one argument, a value for x. Uniform draws 5 samples from a uniform distribution between 1 and 7. This is ARR. We print this. Then we subtract the value x from each value in ARR and get their absolutes. Out of these, argmin gets us the indices of the minimum values. Flat gives us a flat iterator object, so we can iterate over this array. This way we get the nearest value to x, which is 4 here. And again, and again.